Hey BC Calculus, it's Mr. Canfield. Today we're going to learn about telescoping series. So these are called telescoping series because a telescope, if you can imagine like an old school telescope, it's this like closed up thing and then they pull it all the way out and it's got these two ends and then you shrink it back down and the two ends are still there. Like that sort of thing happens with these. So these are some of the last ones where we're actually going to find out what it adds up to. And I really like these. These are fun. So don't worry, not like scary fun. I know sometimes my idea of fun is like really, really awful. These you'll like. So anytime you're asked, like, tell me what this adds up to, telescoping series is going to be an option. And the technique that we're about to use is an option. So here's the technique. N equals, I'll put the N equals in this side. So here's 1. So when N equals 1, we get 1 over 1 minus 1 over 3. And I actually like to write these vertically. A lot of people, they'll just write them out like this, but for me, kind of looking at them as a table, it helps me. So when N equals 2, well, that's 1 over 2 minus 1 over 2 plus 2 is 4. Okay. And believe it or not, we are going to find out the exact number that this infinite number of things like this adds up to. And if you're like, how are we going to do that? It's going to be a pretty advanced technique. So just, stick with me. When N equals 3, I'm being a little bit sarcastic. When N equals 3, let's see, we got 1/3 minus 3 plus 2 is 5, 1/5. All right, and I'm going to go and just do a few more terms. See, when N equals 4, that's 1/4 minus 1/6. When N equals 5, that's 1/5 minus 1/7. When N equals 6, that's 1. I'm going to go until I run out of space on my screen. How about? If you are being very observant, though, you'll see that I'm already in the world of unnecessary writing. Okay, let's look at this. So this is going to go forever, right? It's this plus this plus this plus this plus this plus this plus this. All right. And you're like, what? So this was just like using to think, and this is what the actual sum is. So 1 minus 1/3 plus 1/2 minus 1/4 plus 1/3 minus 1/5 plus 1/4 minus 1/6 plus 1/5 minus 1/7 plus 1/5. And we're going forever after that. And I'm supposed to figure out what this adds up to? You serious? You may be like, no, I'm not going to do that. I refuse. Oh, hey, look, it says minus 1/3, and then later on we add 1/3. Can't we just say, well, those are going to cancel each other out? Cool, that's 2 less terms for us to have to worry about adding all these infinite fractions up. Oh, I see minus 1/4 and plus 1/4. I guess I can cancel those out too. Oh, I see minus 1/5 and plus 1/5. I see minus 1/6 and plus 1/6. I see minus 1/7 and plus. Wait a minute. Everything cancels, except for these 2 terms. 1 plus 1/2 is 3/2. This adds up to exactly 3/2. And this is why I love telescoping series. You list out a bunch of terms. Oh, well, everything cancels out. Done. So, of course, they're not always going to be that out in the open. Let's see. 4 over 4n squared minus 1. So if I were to list these terms out, so like with something like this, it's going to ask, it's not just going to ask, does this converge? A question like this would actually ask, does it, or what does it converge to? Because once you know your tests, you look at this and you easily know. I'm not saying you guys know yet. I'm saying once we go through all of our tests, it's going to be easy to tell, oh, I know this definitely converges. But for the time being, we say, what's this converge to? Well, let me try my hand at maybe trying partial sums. So I'll, to do that, I need to get my terms first. So I'll plug in 1, and that's 4 over 3. Then I'll plug in 2, and that's 4 over, oh, it's 16, so 15, 4 over 15. And I'll plug in 3, that's 4 over 9, 35. I'll plug in 4, that's 16, 64, 63. Oh shoot. This is not looking like anything. Secretly, it is looking like something, but I'm just saying, like, you might go, wait, I'm not seeing any, I don't know what to do here. And, well, one thing we can do is we could pull the 4 out front of everything. We can pull the 4 out. This is, conveniently, we're allowed to do stuff like that. We're allowed to pull out a constant. Because if you think about it, every single one of these is 4 divided by it. So it's the same as doing 1 divided by everything and then multiplying your result by 4. So that might be helpful to think about. And then if I were to think about this as 1 over 2n minus 1 times 2n plus 1, that could be helpful. And maybe, what with a 4, right? Oh shoot, actually I should just leave the 4 in, shouldn't I? Let me just leave the 4 in. So, what if I did partial fraction decomposition on this? So I'm gonna cover this one up. When I cover this one up, I plug in a half, right? So when I plug in a half, I get 4 over 2, which is 2. So I get 2 over 2n minus 1. And then when I plug in negative a half for this one, I get negative 2. So let's see what happens with partial sums with this one now. When I plug in 1, I get 2 over 1 minus 2 over 3. Wait, what's 2 over 1 minus 2? So that's 6/3 minus 2/3. That's 4/3. So this is just, it's another way to write my first term here. And you might be like, well, but that's worse. But now plug in 2, excuse me. 2 over 4 minus 2 over 5 minus 2 over, wait, 4 minus 1 is 3. Then that's 2 over 5. Plug in 3. That's going to be 2 over 6 minus 1 is 5, minus 6 plus 1 is 7. Wait a minute. Cancel, cancel. Cancel, cancel. Wait, they're already canceling. This adds up to 2. So a secret technique, and let me know if this was not detailed enough. I'm happy to like break it down. I'm just kind of on a roll right now, so I realize I might have gone through that a little bit quickly. Oh, Stu even tells us if we do partial fraction decomposition, it actually can help. So, all right. So, what's next? That's it. Cool. All right. So that's telescoping. In the homework, so it says whether the given series diverges or could converge. So, does it definitely diverge or could it converge? Justify your answer to yourself. I should be able to ask you about any of these, and you should be able to give me a good reason why you know it does, or why you know it definitely diverges or could converge. And then for each series, write a rule and term test. So it says write a rule a sub n and use the nth term test. So in this one, you're trying to find out the rule for the terms, and then does it then converge, or sorry, does it then definitely diverge, or could it converge? And then for the last two, they're both telescoping series. 11 is tricky. I hope you figure it out. My challenge to you for 11 would be figure out a way to make it as one thing minus something else, plus one thing minus something else, plus one thing minus something else, and have the pattern be that way, and you'll get there. And we can talk about it if you have questions. Cool, so that's that one. Have a good one, everybody. Bye.